So let's go ahead and look at another example of proving a theorem by using the direct proof technique. So this particular theorem is if n is an odd integer, then n squared is odd. So just to recall a couple of definitions right here, what we use to abbreviate integers is this little double struck z thing. And this stands for just the set of all positive and negative natural numbers, including 0. So -2, -1, 0, 1, 2, yada, 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 like that. So odd integers. So this claim right here, this theorem, is if n is an odd integer, then n squared is odd. So let's just recall real quick. So this little notation right here, this little epsilon looking thing, this means element of or in. So if n is an integer, so we have that it's odd if there exists another integer such that n equals 2k plus 1, right? So that's the definition of odd. Similarly, the definition of even. It's even if there exists some other integer such that we could write n as 2k right here. So you probably have seen these definitions before. But in any case, this particular theorem claims that if n is an odd integer, then n squared is an odd integer. And I see that this is an if then statement right here, which immediately makes me think, it might be amenable to our direct proof technique. And actually, this particular example comes from an example in Rosen's textbook. But the way that he describes it does not use the structured sort of direct proof technique. So I think it's important, since direct proofs are so powerful, that we prove this particular theorem using the structured approach that I have been using so far when talking about direct proofs. So let's go ahead and dive right into the proof of this theorem. So recall the very first step of our direct proof technique is we assume the hypothesis right here. This is a P implies Q statement right here, so we're going to assume this part right here. So I've started my direct proof technique and I have made my assumption. And you remember the next step is we have to make some sort of argument, with the goal being to show that n squared here is odd, and that will conclude our proof. Okay, so what do we have to work with? Well, the only thing we have to work with is our hypothesis. N is an odd integer. So let's go ahead and go back to the definition of what it means to be an odd integer and utilize that. So since it's an odd integer, by definition of being an odd integer, we know there exists another integer such that n equals 2k plus 1. Okay, so that's fine. But remember, what I'm trying to show is that n squared is odd. So in my argument, I see all I have is an n and I want to get to n squared. So let's go ahead and see what happens if I take this expression right here and square it. Okay, so I've squared both sides of this equation right here. And if I go ahead and expand this thing out, I get 4k squared plus 4k plus 1. Okay, well, how is that going to help me? Well, I'm trying to show that n squared is odd, and if I look at this expression right here and recall the definition of odd, I want to show that it's 2 times some other integer plus 1. So actually, I can simplify this thing, and I could write this as 2 times 2k squared plus 2k plus 1. So note that if we let m be this little expression right here, we see that's, yeah, it's definitely an integer. We have an integer squared times an integer plus another integer times another integer. That's great. That's all fine, well, and good. M is definitely an integer right here. So what have we actually shown? We have shown that there exists some m, in particular that m right there, such that n squared equals 2 times it plus 1. Well, that's just the definition of being odd. So therefore, by definition, n squared is odd. So using my structured format of a direct proof, I have made my assumption, this right here, I have made my argument, and then lastly, I have my conclusion, and that will allow me to write that this proof is complete. So you might notice a couple of things that we have done. One is, in the midst of this direct proof, I relied on a particular definition. I relied on the definition of something being odd. And then I looked at my conclusion and I saw, how can I get from my assumptions to my conclusions right here? Well, I started with an n. I want to get to an n squared. So that suggests to me that I might want to square something. So usually in the midst of a direct proof, what you want to do is rely on definitions and see how you can connect up your hypothesis, which you got to assume because you're using the direct proof method, and then use those to be able to get to your conclusion right here.